Hi everyone. In this lecture, we're going to talk about link layer switches. A link layer switch is a device that takes an active role in forwarding and storing Ethernet frames. A switch examines an incoming frame source and destination MAC addresses, and then selectively forwards this frame to one or more outgoing links. Note that a switch still uses the underlying Ethernet protocol of collision detection, carrier sense multiple access. The switch is transparent. Hosts within the network are unaware of the presence of switches in the network. Switches are also plug and play and self-learning. Switches do not need to be configured. You can just buy a switch from a vendor and plug it into a network. This reduces a network administrator's workload. To get a deeper understanding of how a switch works, let's look at the diagram on this slide. The diagram shows the star topology. 6 different hosts are directly connected to the switch on different interfaces in a star configuration. The switch can buffer packets, much like a router. Because of this, the switch can process incoming Ethernet frames on different interfaces simultaneously and independently without collision. We can say that each link is in its own collision domain. Let's look at the diagram in more detail. How does the switch know that device A' is reachable via interface 4 and device B' is reachable via interface 5? The answer is each switch maintains a switch table. The table includes the MAC address of each host connected to it, the interface to reach that host, and a timestamp. This looks very much like a routing table. So how does the switch populate this switch table? And how does the switch maintain this information? A switch is self-learning. It learns the location of the senders, that is, which interface they are connected to, by examining the incoming frames and extracting the source and destination MAC addresses. The switch then records the sender's MAC address interface pair in the switch table. Here's an example of switch behavior. If the switch receives a frame and the location of the destination MAC address is unknown, the switch floods the frame out of all of its interfaces except the interface that has received the frame. If, however, the destination MAC address is known, that is, it is in the switch table, then the switch will selectively forward the frame to the destination host via its attached interface. What if there are not sufficient switch ports to handle all the devices in the organization? Or if the devices are too far apart, such as on a separate floor? Then additional switches can be used and they can be connected. How do these cascaded switches work? Through self-learning, just like a single switch does. In this diagram, suppose that device A sends a frame to device G. Suppose that device G's MAC address is not in any of the switch tables, and device A's MAC address is only in the switch 1 table. Then switch 1 will flood this frame out all of its other ports. Switch 4 will receive this frame, record that device A can be reached via switch 1's interface, and flood the frame out of all its other ports. Switch 3 will receive this frame, record A's MAC address, and that it came from switch 4's interface, flood the frame out of all its other ports. Now device G will recognize the device address in the frame as its MAC address and send a reply. Switch 3 will learn the interface that is attached to G and forward the response back to device A via switch 4. Switch 4 will learn that G can be reached through switch 3 and will forward the response to switch 1. Switch 1 will learn that G can be reached through switch 4 and will forward the frame to device A. How would the switching tables look in this scenario? For simplicity, we have shown only 4 interfaces in the switch tables. For this scenario, assume that the maximum timeout is 60 seconds. The tables show that switches 1, 3, and 4 have just populated the tables with the information that they have learned for devices A and G. Switch 2 has learned about device A, but not device G. Though not part of the scenario just described, this slide also shows what happens when switch 3 entry for device A is timing out. Here we see a diagram of a typical small LAN segment. All the clients and servers in the organization are connected to the switches. All of these devices are in the same IP subnet. These devices can connect to other subnets and the internet via a router. Let's look at the similarity and differences between switches and routers. Both switches and routers store and forward packets, but routers operate at the network layer, whereas switches are link layer devices. Both types of devices use forwarding tables. Routers compute routing tables using routing algorithms and IP addresses. Switches populate their forwarding tables using MAC addresses via flooding and learning. The next subsection will discuss VLANs, virtual local area networks.